So let us start with evaluating. Right? Determinants by row reduction. Okay. First, let's start. The first thing is obvious. This is obvious. Let A be a square matrix. If A has a row of all zeros or a column of all zeros, if A has a row of all zeros or a column of all zeros, What is the determinant of A? What do you think?
0.
Yeah, good. Good. And the second thing we discussed actually last time, that let A be a square matrix, then determinant of A is determinant of A transpose. Okay, now today is about, so we did about how to find, evaluate 3 by 3 determinants by using cofactor reduction, not cofactor expansion. So suppose you have a 4 by 4 determinant. So today we will be talking about those things. That's the end. Row reduction, they say. So, okay, this is number 1. So what you have, suppose you multiply, so the first row by K. So that is equal to K times this determinant, A11, A12, A13, A21, A22, A23, A31, A32, A33. How to summarize this? So this is determinant. So determinant of B is K times determinant of A. Huh? Right? This is B, this is A. Huh?
Mic on.
So you write this way. In the matrix B, the first row of A, the first row
Mic off.
of A was multiplied by K. This is B. This is A. K times determinant. I should call this. Yeah, better. This is better. Next, suppose you do this. You interchange 2 rows just once, by the way. So I had A11, so I interchanged 2 rows. A21, A22, A23, A11, A12, A13, A31, A32, A33. That is minus A11, A12, A13, A21, A22, A23, A31, A32, A33. That means what? So here what is happening is determinant of B is minus determinant of A. So in the matrix B, the first and second rows are were interchanged. And finally, it's something like this, you see? This is very interesting, number 3. Second row, you multiply the second row by factor k and add it to the first row. So it's like this: a11 plus k a21, a1 a12 plus k ka22, a13 plus k a23, a21, a22, a23, a31, a32, a33. Okay, this guy is equal to a11, a12, a13, a21, a22, a23, a31, a32, a33. So what is happening here is determinant of B is the same as determinant of B. So in the matrix B, a multiple of the second row was of A was added to the first row. So you can summarize this. This is the important summary. This is the important summary.
Professor,
Yes, please.
could you go back up, please? Thank you.
Is this okay?
Yeah.
Is this okay? Ready? Okay. Theorem. This is very helpful. Let A, we can generalize this like as follows. Let A be an n by n matrix, square matrix A. If B, this is very important to remember. If B is the matrix, that results when a single row or a single column of A is multiplied by a scalar, is multiplied by a scalar k, then determinant of B is k times determinant of A. B. If B results, if B is the matrix that results when two rows are interchanged, when two rows or two columns of A are interchanged, then determinant of B is minus determinant of A. So just if you just change it once, that means if you do this twice, then determinant of B will be minus determinant of A, that is determinant of A. see if B is the matrix that results when a multiple of one row of A of one row of A is added to another or when a multiple of one column is added to another, then determinant of B is determinant of B. So I want to show you a very simple example. Say, for example, we know how to do this, right? But let's do it. But so A is the matrix, say 0, 1, 5, 3, minus 6, 9, 2, 6, 1. Now, we can do many things. We can find its determinant by using a cofactor expansion. Let us do a cofactor expansion along the first row. 0 times minus 6 minus 6 9 is 54, no? Minus 6 minus 54. Plus minus 1 times 3 minus 18 plus minus plus 18 minus 12 plus 12. So that is minus 60 plus 15 plus 150. So that is 105, I guess. No? Oh, no, sorry. So this is 0 times, exactly. Sorry, wake up. So 0. So this is 165. Let's do it in a different way now. A is this. So what's the idea? The idea is something like this. You see, suppose you have a matrix that looks like this. Look, lambda 1, 0, 0. No. I won't go that far. Say A, B, C, then 0. X, Y, 0, 0, P. You see, what is this determinant? It's extremely simple. If I determinant of A, that means if I expand along the first column, I'll do it along the first column. That's it. So if I do it along the first column, I simply, so then I will multiply A times, so AXP plus minus 0 times something out, 0 times something out. So that is just the product of the diagonal elements. product of the diagonal elements. So that is easy. So my goal is using all those operations that I showed you, how to reduce this matrix in this form. And this is called a triangular matrix, lower triangle. Well, we do this. Look. So determinant of determinant of A is 0, 1, 5, 3, minus 6, 9, 2, 6, 1. Interchange the first row and second row. Then you introduce a sign, negative. Take the factor 3 out. You get okay, I'm almost there. I just want to make this 2 0. See? This 2 I want to make it 0. So how will I do this? There's a very easy way to do this. Multiply the first row by minus 2, add it to the third row. So multiply the first row. Look at my pen. First row by minus 2, add it to the third row. So this remains as it is. This remains as it is. We multiply this by minus 2 and add it to the first row. No, multiply the first row by minus 2, add it to the third row. 0, minus 2. Minus 2 times minus 2, 4 plus 6, 10. Minus 2 times 3, minus 6 plus 1, minus 5. And that is no, 6 is wrong. Ah. Ha 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 ha. 3, 6. Take 3 common. Oh, this will be minus 3. No. Minus 3. Minus remains as it is. I took 3 out. Then I get 1 minus 2, 3. No, this is okay. This is okay. This is okay.
Could we then multiply the first
1
row?
minus 2, 3, 0, 1, 5, 2, 6, 1. Okay. Then this is also correct. This is also correct. This is also correct.
Yes. Now, can you multiply the first row by
Yeah.
5?
You are right, but I don't need to do that. I'm going to now I'm going to, this is what I'm going to do. I will expand the determinant along the first row. As I showed you, if you have first column, first column. As I showed you, just multiply the diagonals, that's all. That is, oh no, you cannot multiply just the diagonals. Oh, but that's okay. No, sorry. Okay, there was a mistake there. No, 0, 0. Oh, I wanted to try to make that 0. Okay, yes, we can do that. Okay, I can do that, but I can finish it here, by the way. But that's okay. You had a good point. Minus 3. I want to make this guy 0. Let me show you here, my pen. This guy 0. How do I do that? Exactly as Early was saying. I think that, no, I will not do that. You know why? I will finish it here. I will finish it here because I don't need to do that. Why? Because this is minus 3 times 1 times this determinant. Minus 5 minus 50. That's enough. But now let me take a problem like this. Say you have 1 minus 5. Question is determinant of A. So determinant of A is 1, 0, 0, 3, 2, 7, 0, 6, 0, 6, 3, 0, 7, 3, 1 minus 5. Interchange the second and third row. 1, 0, 0, 3, 0, 6, 3, 0, 2, 7, 0, 6, 7, 3, 1 minus 5. Add, now multiply first row by minus 2. See what I'm going to do. What is the leading term in the second row? 0. So I'm there. What's the leading term? I want to make the leading term on the third row 0. I want to make the leading term on the leading two terms in the fourth row 0, 0. As many zeros as I can get. Okay, so this is what I will do. Multiply the first row by minus 2, add it to the second row, third row. Don't disturb the second row. Minus 2, so that is 0. Minus 2 times, that is 7. Minus 2 times 0, that is 0. Minus 2 times 3, minus 6, 0. Multiply the first row by minus 7, add it to the fourth row. 0, 3, into the 0 plus 1, by minus 7, no? Minus 7 times 0, yeah. Minus 7 times 3 is minus 21, minus 21 minus 5, minus 26. Okay, so you see, I'm almost there because now I can just, yeah, I'm almost there. Interchange the second and third rows. The whole idea is to make it as simple as you can. 1, 0, 0, 3, 0, 7, 0, 0, 0, 6, 3, 0, 0, 3, 1 minus 26. The game is now very simple. What I'm going to do is I will expand this determinant along which row? Can you tell me?
Professor, could we multiply? Oh, no, sorry.
No, that's okay. Why don't you all come to class on time? Minus, why don't we do this? No, but we are almost there, you know. Okay, so here it is. So this is, let me expand along the first column. Then it is 1 times this determinant. First column, 7, 0, 0, 6, 3, 0, 3, 1 minus 26. Now I can do this straight away, but I won't do that. Oh no. This is very easy because I will simply, I can see what is happening. I will simply expand this 3 by 3 determinant along the first row. So 1 times 7 times 3 times minus 26. Nothing else, everything is 0 now. Where did the 3 go? What do you mean, where did the 3 go? 1003. Where did the 3 go? The 3 is in my pocket. Listen, I am expanding this determinant along the first column. First column. So 1 times this determinant. Yeah, now 1 times this determinant, the weight. Then plus, minus, plus, minus, plus. Plus 0 times some determinant. 0 times some determinant. 0 times some determinant. They're all gone. So that is, can somebody tell me what this should be? 26 times 21. No? 26 times 21, 546. Exactly. Minus 546.
Professor,
Yeah.
I think the classmates are talking about how you convert this into 3 by 3 matrices.
Yeah, because come on, this is a pretty. I am expanding along the first column. So 1 times this determinant. And then what? First column, doing along the first column. Then 0 times something, 0 times something, 0 times something. They're all gone. Okay, do this, practice this.
Yes, thank you.
Good. Practice this. 3, 5, minus 2, 6. Let us practice this. 1, 2, minus 1, 1. 2, 4, 1, 5. 3, 7, 5, 3. You must, on the exam, you must show the steps, right? Determinant A, just the way I'm doing, that's it. You don't have to write that, oh, I'm multiplying this by blah and that, and no, that's stupid. First thing, I always want the guy sitting in the first row, first column, let's start that with a 1. So interchange the first 2 rows. Then I want to get as many zeros, no? That's the ball game, right? That's the name of the game. There is no space here. This will break. I want to make this guy. I want to make this guy, this 3, I want to make it 0. I want to make this 0. I want to make this 0. Well, very simple. Multiply the first row by minus 3, add it to the second row. Minus 3, minus 6 plus 5. Minus 3, no? 3, minus 3, minus 1. 3, minus 2, 1. Minus 3 plus 6, 3. Do the same with the third row, minus 2 plus 2, 1, 0. Minus 2 times 2, minus 4 plus 4, 0. Minus 2 times 2, 2 plus 1, 3. Minus 2 times 1, minus 2 plus 5. 3. Multiply by this by minus 3, minus 3 plus 3, 0. Minus 6 plus 7, 1. Minus 3, no? 3 plus 5, 15. 3 plus 5, 8. Minus 3, I'm multiplying by minus 3. Minus 3, first row by minus 3. 3 plus 5, then minus 3 plus 3, 0. I've already got what I wanted. I will simply expand along this column. So this is minus 1 times this determinant. So it boils down to doing this. But I'm going to make it even more simple. And simply add, multiply the first row by 1 and add it to the third row. Now, expand along this column. Then you are left with only this part. 9 minus 27 minus 18. Ah. Okay, isn't that fun? Yes or no? That's fun.
It is fun.
It is fun. Oh, Shania Khan says nah, no. And Lindita says ah. But Early, our friend Early says, can we do another? Yes, of course. I will give you lots of practice. Wait. Yeah, let's do this. Come on. Evaluate the following. So, yeah, this is, so wait, okay. Now you can do this by a cofactor expansion, but you see, that is a little complicated. That is something that you have to do. If I ask you to find the inverse, then you have to find all that using the adjoint and all that. But you see, this is easy. So, determinant of A, 3 minus 6, 9. Take 3 common, 3 factor out. I want to make this guy 0. Multiply by the first row, multiply the first row by 2 and add it to the second row. 2 minus 2, 0. Minus 2 times minus 2, minus 4 plus 7. I'm multiplying this by 2. 2 times 3, 6, minus 2, 4. That's it, I'm done. I will simply expand along the first column. And when I have a 0, 0, I don't have to worry at all. 3 times 1 times, that's it. Here it is. This determinant. 15 minus 4. So 3 times 11. 33. Why don't I give you a 4x4 one?
Can you give us like 5 minutes to practice on our own?
Yes, I'm giving.
Okay.
I will give you time. I will give you 10 minutes. 2, 1, 3, 1. Definitely. 0, 1, 1, 0, 2, 1, 0, 0, 1, 2, 3. Do it, let's say. Find the determinant of A. It's now 2:17 p.m. Give you time till 2:25. This is very easy. Just first of all, interchange the first two rows, you see? Mm. Then you multiply the first row by -2 and add it to the second row by -2, no? By -2. Uh, by -2. -2 plus by -2. That's it, you're done. Because I will now expand along the first column and then I have -1 times this determinant. But that's easy. 1, 1, -1, 2, 1, 0, 1, 2, 3. Now, you can do it very easily, but why? But let us reduce this determinant. Let us have a little more fun. 1, 1, -1, 2, 1, 0, 1, 2, 3. See the fun. That is -1, 1, -1. Multiply the first row by -2, add it to the second row. -2 plus 1, -2, 2 plus 2. Multiply the first row by -1, add it to the third row. -1, 2, -1, 1, -1, 1 plus 3, 4. The game is over. Yes. Now you are left with this. I'm going to expand along the first column. -4, -2. -1, -6, 6. Yes. Do another one. Let me give you a 3 by 3 and then I will give you a 4 by 4. Yeah, why not do this one? Let me give you two 3 by 3. And another, this time a 4 by 4. This is a good one. 1, -2, 3, 1, 1, -2, 3, 1, 5, -9, 6, 3, -1, 2, -6, -2, 2, 8, 6, 1. No? Okay. Okay, do these three. Let's see. I give you time. I give you I give you 10 minutes. Yeah, 10 minutes should be enough. Yeah, of course, for square matrices. Hello. The determinants are only valid for square matrices, my friend. Hmm. When you're doing determinants, they're only for square matrices. Okay, do numbers 3, 4, and 5. Have fun. Let's see. Then I will give you some other kinds of questions. Have you finished copying 3, 4, and 5, please? Okay, let us see. Hmm. Number 3. Take 3 common from first of all, take 3 a factor out. 1, 2, minus 3, 0, 0, minus 2, minus 2, 1, 5. Don't disturb second row. I want to make this guy 0, so multiply the first row by 2 and add it to the third row. 2 times 2, 4 plus 1, 5. Minus 3, 6, 2 times minus 3, minus 6 plus 5. Okay,
Professor, I have a question. Could you do it like adding +2 in row 3? So it could be 0 and then 2 and 7.
I'm sorry? You can do many other things. You can do many other things. It doesn't matter. But I prefer always to do this, and then my game becomes very easy. 3 times, 1 times, and that's it. 0 minus minus 10. How many of you got this answer?
Isn't it easier just to flip the second row with the? Okay.
Yeah,
Why?
no, you can do that. You can do that. You can do lots of things, but as long as you get the correct answer.
Okay, because that one's just like one step, and then you just have to multiply the negative
Okay.
2 out.
Okay, yes. Perfect.
So, Professor, the answer will be a 30 no matter how we do it, right?
Huh? Oh, answer is the same, of course. Absolutely. Square matrix will has one and only one determinant, unique determinant, please. This is nice. This is multiply the first row by 2 and add it to the second row. Minus 6 plus 4. Then multiply the first row by minus 5, add it to the third row. 15 minus 2. Now your game is over because I'm now going to expand along this column. And that remains. Okay. Do the same thing here. Multiply by the first row by minus 5, add it to the second row. Minus 5, no? 10 minus 9, 1. Minus 15 plus 6. Just multiply the first row by 1 and add it to the third row. Multiply first row by minus 2, add it to the fourth row. 4 minus 2. 4 plus 8, 12. Minus 2, no? Minus 2, just 3. 10, 3, 6, 26, 0. Now I'm going to expand this along this column. Therefore, this determinant remains. You don't have to draw all these pictures on the exam, certainly not. 1 times this determinant. So I have 1 minus 9 minus 2, 0 minus 3 minus 1. 12, 0 minus 1. Well, multiply the first row by minus 12, add it to the third row. No, you don't. Multiply this by minus 12. 12 nines are 108. 24 minus 1, 23. I have nothing more to do because I'm now going to expand along this column. So all I have is 1 times minus 69 plus 108. Hello, how much will that be? 49, I suppose? No, 39. Okay. Can you do this problem? number 5. Number 6, show that this determinant 1, 1, 1, A, B, C, A squared, B squared, C squared is B minus A, C minus A, C minus B. Do it. Let's see. No point taking break because now we are almost finished. I have some nice, very nice problems for you. Few more, and then we can. That finishes chapter 2. And yeah. So then I want to, after finishing some problems, talk about the quiz. So this is really fun. You see, what you do is you multiply the first row by minus A and add it to the second row. Multiply the first row by minus A squared. Add it to the third row. And now you are done because I'm going to expand along this column. So your answer is B minus A, C squared minus A squared, minus B squared minus A squared, times C minus A. But you observe that you have some common factors. So that is B minus A times C minus A. And then you have C plus A minus B minus A. So that is B minus A, C minus A, C minus B. Hey. B minus A, this is B plus. Good. That's it. Okay, here is a very interesting question. Wait, give me time. This is number 6. Given that this determines A, B, C, D, E, F, G, H, I is minus 6. Wait. Very good. Okay, given this determinant is minus 6, find, you don't have to do it, you should be able to do it orally. That's equal to what? Can somebody tell me? will tell me? Quick. Hmm?
Isn't it plus 6?
Huh?
Isn't it plus 6?
Plus 6. Why? Let's see. You see, okay. The first row became the third row. Therefore, you introduce a negative sign. Yes or no? Hello?
Yes. Yes.
Then it becomes plus 6. But then, so it's like this. Right? And that's what you wanted. So it is. But this determinant is minus 6, so this is minus 6. Hmm? Got it? How about
Yes.
this?
Would it be just sits?
Sorry?
Would it be like regular sits or plus sits?
What do you think? You tell me. Hmm?
I think there's plus sits because it's
Plus 6? You think it is
Yeah.
plus 6? Hmm?
yep.
You think it is plus 6, right? Okay, let's see. Our friend says that this is plus 6. Okay. Minus GHI ABCDEF. Our friend seems to be correct. And this is exactly what we wanted to find out. So, this implies GHI DEF ABC is equal to minus of ABCDEF GHI, which is minus of minus 6. Is this given to be minus 6? Yes. And therefore our friend is correct. How about this one? If you understand this set of problems, then you have understood this. Then we can go. Finish chapter 2. What's the answer?
Is it 72?
Hmm?
Is it 72?
72. Let's see. Let's see why our friend is saying this. Is absolutely correct. Very good. How about this? Stanley Lee says -6. Let us see whether she is correct. We are given A, B, C, D, E, F, G, H, I is -6. Okay, so that's given to us. But this is equal to A plus D, B plus E, C plus F, D, E, F, G, H, I. Now if you multiply by -1, then this becomes minus A plus D, B plus E, C plus F, minus D, minus E, minus F, G, H, I. So this implies this determinant A plus D, B plus E, C plus F, minus D, minus E, F, G, H, I will be minus of -6, that is 6. Hmm? How about this? Anybody? Why don't you send me the answer?
-6.
Huh?
-6.
Negative 6, exactly. Exactly. Because this is exactly the same as A, B, C, D, E, F, G, H, I, and that is -6. Perfect. How about everything? How about this? Yeah? Let's see who can say this. Hello, please. Hello, please. Somebody give me the answer, please.
It's -12.
Ah, well, this is equal to,
Yes, it is.
yes, it is. Yes, it is. Yes, it is. My friends fell into the trick. I loved that. Hmm? Let us go right at the beginning of today's class. We made an observation which is very simple. If A has a row of all zeros, okay. Okay, now, okay, sorry. How can it be 12? How can it be 12? Come on. There are two rows identical. So the determinant must be 0. How do you get this? This is 2 times multiply the first row by -1 and add it to the third row. Now you expand along the third row, or you could have done it. You could have done it a more simple way. You could have kept these things as A, B, C, and then multiply the third row by -1 added to the first row. Now, what is this determinant? 0. They fell into that trick. Hmm? Okay, 2 more. Yes. This should be easy.
-36.
How much early? 30?
36. 36.
Okay, let's see. I think you are right. So that is equal to minus 6. Then, so this is equal to 2 times so 2D, 2E, 2F, G, H, I is minus 12. So A, B, C, 2D, 2E, 2F,
Is there a negative
A, 3B, C.
18?
Wait. I want to get all the. And then what you said is absolutely correct. Is this what you said? Arlie?
I believe I said
Now what is your answer?
negative 26. Yes, that's correct.
Good. And finally, this one. What's the answer?
Negative 72.
Huh?
Negative 72.
Negative what?
72.
Negative 72. I think you are right, because minus 3 A, B, C, D, E, F, G, H, I is minus 3 times minus 6, 18. So what you're getting is minus 3A, minus 3B, minus 3C, D, E, F, G, H, I is 18. So now if I multiply it by 4, by minus 4, so then if I just add, oh, no. Huh? Yeah, yeah. No. Oh, no. Okay, 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 okay. Yes. Who said minus 72? You said minus 72 or 72?
I said negative 72.
Thank you very much. Okay. That completes chapter 2 very, very carefully, thoroughly. Now, the quiz 1 is on September 24. That means exactly 1 week from today, exactly. And there will be 3 questions. Yeah. So, class meets at 1:40. Therefore, I will give you 2 p.m. to 2:30 p.m. 3 problems. So one will be find inverse of a matrix using adjoint. 3 by 3 matrix. So you find the matrix of the cofactors, then adjoint is the transpose of that, and so number 2, solve a system of 3 by 3 question system of linear equations using Cramer's rule. Evaluate, maybe I will give you a 5 by 5 determinant, huh? Just for fun. 4 by 4 or a 5 by 5? 4 determinant or a 5 by 5?
We're good with 4 by 4.
Using row reduction. Row reduction methods. I'm going to write few things here which I wrote for my, just a minute. Sent. Okay. As I am writing, yeah. So this is important. System of equations. It cannot be system of linear equations. Cramer's rule, you know that. Okay, the quiz is just like the exams, right? Will be proctored each student must be visible on the screen for the entire quiz. Do not copy the questions. Only number them. So the quiz must be returned by 2:40 p.m. by email. And this is the crucial thing. The entire quiz must be submitted as a single PDF file, nothing else, as your name, your first name, last name, your name, dot PDF. No math 231, blah, 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 date, nothing. This is what I want. So I will repeat this next Tuesday again. Tuesday we go back to the remaining parts of chapter 1. This will be a practice for you for the exam. Yes, question.
Yeah, I don't think next Tuesday we have class.
No, next Tuesday we have class.
Which Tuesday they're following the Monday schedule?
No, excuse me.
It's the 28th.
29.
Oh, okay, got it. Thank you.
Yeah, we do have class next Tuesday.
Okay.
Next Tuesday, I will give you a quick review. That's just a 15 minutes review. We did a lot of problems today.
Professor, do you mean 3:30 instead of 2:40? What time does the quiz start?
2:30.
But you said to.
No, 2:30 because then I give you time. That's what I'm going to tell you, explain to you.
You just said this quiz is going to start at 2 p.m. and it's going to end at 2:30.
Yes.
Okay.
Yeah. So what I'm going to do, what I'm going to tell you is this. This is very important. All of you should be visible on the camera. Like this, I can see only 4 people. Only 4. But I'm not counting myself, so then only 3. Arlie Evans, Amit Charan, Caesar, and I cannot see anybody else. So that's not allowed, right? If I cannot see you on the screen, your exam will not be accepted. Yeah, I can see Sebastian. Anyway, that's not for today. It's for Thursday for the quiz. Well, let me finish, then I will take your questions. So the way it's going to work is this. You finish this in half an hour, and then you say, Professor, I am done. May I go to scan it? But I'm taking time to scan it. Okay, I will take time to scan.